And Mr. Pham, make it a little bit bigger.
We'll see. Just a minute.
Okay.
Is it okay?
Yeah, that's not too bad. Hey, right there, Mr. Pham.
Just
See?
a minute.
Oh, okay. Yeah, you need to make that bigger.
Is it okay?
Yeah, it's not too bad. I mean, you might have to move it back and forth a little bit, but bring it out a little bit more.
That's good for on the right.
Now you got to move that side. Yeah, that's not too bad right there.
Hey,
What about that box, that square box where you do maximize?
maximize.
Yeah, that's at the top right. There's a box in the middle. Yeah, is that? Can't you do maximize? And then you could uh, do that on the ends.
That's the only thing I can do.
Yeah, that look that's about as you just have to move it around when you're talking.
Okay. Basically, this is the IC 191.
Right, 74 191.
191. That means binary counter.
Mm-hmm.
Okay. That's
Okay.
counting from 0 up to 15 or 15 down to 0. Count up and count down. And also, you can loading any number to the counter. Okay.
Okay.
So if you're looking into the schematic and you see pin 4 input, correct?
Yeah, I can see pin U4 pin 4, right?
Yeah.
That has to be ground. It has to be ground.
Why? Now, JDEN, that means counting enable, active low.
Mhm.
So that's why they drop. Okay, the next U4 pin 5. That for down or up. That means count up or count down. If I count up, what pin 5 supposed to be?
Count up would be 0
0. Count up. And 1.
because it has that little bar over the U, so that
Right,
tells you that's active low.
right. That means 0 at pin 5 counting up. 1 at pin 5 counting down. The next 14, that means the clock will be 0 to 1. Transition,
Because it's a positive clock.
right, P clock. And pin 15, 1, 9, 10, 9, A, B, C, D. That's the load data. You can set pin A, pin B, pin C, pin D. So if you apply pin load 11, 0, then the output U4, QA, QB, QC, QD equal A, B, C, D.
Right.
Okay?
Mhm.
And that output go to U5, U44,
That's a buffer.
just a buffer. If pin 10, output pin Y1, Y2, Y3, Y4 equal A1, A2, A3, A4.
Mhm.
Okay? Now, only two pin left over, pin 12 and pin 13. What happened to pin number 12?
Well, that's the max min. So, only thing I can remember you saying is that the data that goes in 12 and 13 goes to U2A, and that has to do with
Yeah,
when you finish counting.
I just talking about pin 12 first.
Oh,
The
okay.
input or output?
Is that input?
No, output.
Oh, that's output. So RCO is output then.
Right. Now,
I mean, wait a minute. Pin 12,
normally
pin 12. Say that again, Mr. Pham. Pin 12 is what? And pin 13 is what?
output,
No, which one is output?
both.
Both.
Okay?
Okay, go ahead.
Now, pin 12, normally the 0. When U4 go up to 15 maximum, pin 12 go up. Okay?
Okay.
RCO 13 for counting down. Normally high. When the counter count down to 0, pin 13 going up, going to down to 0. Okay?
Okay.
And both in output go to U2A.
That's an AND gate.
and get. Okay.
So
Normally, one output high, one output low. So,
if one of those is high and one of them's low,
yeah.
then
But,
then then the
but
output to the AND gate will be 0.
yeah, however, when the counter go up 15 and pin 1 going high, pin 13 high all the time. So high and high equal to pin 3 equal 1.
1.
Okay?
Okay. And you said pin 2 on U2 is high all the time? Or
Yeah, they go low when the counter count down to 0.
okay.
Okay? So when the counter go up to 15, pin 1 go high, pin 2 still high. So high and high, pin 3 will be high. And pin 3 go into make the clock to U3. U3 a D flip-flop. Output not kill. Connect back to D. That only telling you when they get a clock, output U3A will be toggle.
Okay. So
It
in
just,
other words, when when you get the output from U2 3, it goes all the way around, it goes to the clock U3 3, and then when you get that clock, that's when and D equals Q or not Q, then you get the toggle.
that means when you get a clock, U3A toggle.
Okay.
So pin 5, okay, it would 0 now go to
1.
so if they go to 1, okay, they go back to up and down.
So
So
then it's
now,
going to, if it go to 1, then D is going to be 1, which is count down. It'll start
right,
counting down.
that means after they go up, automatically they will be count out.
Hmm.
That's how they work.
Yeah.
And now P1, PD1 load, go to the buffer. That's the buffer 125. If pin 5 0, pin 6 0,
Right.
pin
And
5 1.
Mr. Pham, just real quickly, when we talk about buffers, for buffers, whatever go in comes out, right?
Exactly.
Okay, go ahead.
Okay. Now I need to talking about this one. You know, the thing is, my iPad is not working anymore.
Now you got to get a new one.
Well, next week, I think Wednesday, I, I buy the new one. Okay. Now, if you want to load, then load have to be,
0, it's got to be low.
okay? So they can tell you, number one, get load. Okay. That means load will be 0, right?
Right.
Okay. And they will be loading what now?
Depends. It could be loading 5, like 0101. It could be
Yeah.
loading one
However,
zero one.
however, I follow the timing.
Right.
What A equal?
For load, A is high,
What B equal?
B is low, C is high, and D is high.
So that's a binary. So on the hex or in the decimal, they will be 08 1101, right?
1101. Let me see. That's D. Yeah.
Okay. So I can that one follow the D equal to 1. D C
C. C equal 1.
equal 1.
D equals 0.
D
No, B.
that will be B, right?
No. You're right so far. You need to move over to the third one. Yeah.
B.
Yeah. D equals 0. And A equal 1. The only thing is 0 is B. Yeah, there you go.
1101.
1101.
That's D,
That's D. Yeah.
right?
Right.
Number 13.
Correct.
Okay.
Hey, Mr. Pham, so we don't forget, because you're on load, see how the dashed lines go down? And the clock is in part of that. So how, but you know
Now,
what I'm talking about, right?
if you're looking here, okay, not 0. You
Yeah,
get
load is
that
0.
input here. You see that?
Hmm. That area where the dashed lines at in between that is load.
Goes going down.
Right.
Now you get QA. See that?
Right. QA is high.
QB. Okay.
QB is low. And C and D is high.
Then number 3. Output. Okay. QA. Okay. QD equal 1, right?
QD is, yeah, 1.
QB 0.
Wait a minute, you going QD, shouldn't it be C
Oh, you see
equal 1?
1. Okay.
And
QB.
QB equals 0. And QA equal 1.
So 08, 0D, right?
Right.
So that done for that's number one.
Mhm. Hey,
The
Mr.
load,
Brown,
the
I don't,
load will be higher.
okay.
That means load zero, you cannot do anything, cannot count.
Right.
Okay? So that's why we don't care about that thing.
Hey, Mr. Pham, I don't mean to make a big deal out of it. I don't mean to make a big deal out of it. But see how load is between those dashed lines that go up and that go from top to bottom, right?
Right. You can
Okay.
you're
But
loading right here, going down.
right. But what I'm saying is part of the clock is inside of that.
Now who care? It's not controlled by the clock,
Oh, because it ain't enough of them, huh?
so you don't care. Clock you don't care.
Yeah, right. Don't care. Okay, go ahead.
Yeah. That's what I want the student look into the timing. They understand. And now if they looking on the output maximum minimum RCO, you can see max minimum will be zero, right?
Right. Max min is 0 and RCO is 1.
Right. Okay. Then you can loading a next, right?
Right.
So we're not talking about that. We're talking about counting.
Right.
Okay, counting. If you're looking on the counting, okay, this is counting the clock here. Okay,
Right.
you see the clock, okay, 14 for counting. Okay, load must be one.
Yeah, because you don't want to load. So you got to
Yeah,
change it from
the
0 to
load
1.
control. Okay, and when you apply the clock, P clock, right?
Right. P clock.
Okay, 2.3. Now, you try to see on that one. Before you apply the clock, what the output counter.
Mhm.
The counter after you loading, they number 13, correct?
Right.
So
Oh,
now
before
apply the
before you
clock,
start counting.
they go to
14.
right. Okay. So when you apply the clock, okay, counter going from 13 to 40,
Right.
right?
Right.
Okay. Now, this is the first clock. This is the second clock. Okay?
Okay. Where's the first clock again?
Here,
Okay, all right, got it. First
0 to
clock.
1.
Right,
And now go next one, 0 to 1.
right, second clock.
Okay. Then the counter will be go to what number?
15?
Okay. Go to 14 to 15. All
Right,
right.
right.
Okay.
Mm-hmm.
However, if you're looking into max output, make me. Okay. Going correct.
Let's go.
See,
It's high when you go to 15.
they go high.
Right,
Okay. Then RCO going low.
go low when you go to 15.
However, you can see you get a high here, you get a high here. See that?
Right,
So both maximum RCO will be high. Okay?
okay,
You can see that one here before the 50,
right.
both high. Okay. Now,
Hey, Mr. Pham, you should probably put, well,
if both high,
yeah, I got you.
L2A3 high, right?
Right. I was going to say on 2.5, you should,
L2,
before you go to 15.
L2A pin 3. That is clock for the flip-flop L3A. Okay. L3A. Connect, not kill. today. Will toggle. And now, hey, what?
Because Q was 0, not Q is 1. Yeah.
The thing is they got they connect not Q
Right. Not Q is 1.
into D.
Right.
We don't care one or not. Not Q connect to D.
Right.
Every time the clock is coming, they toggle.
Right. Okay.
And the output was 0. Now they toggle, they be 1.
Right.
So that will be telling you, okay, now I can say
And the toggle 1 is going to start counting
Q,
down.
D, okay, A, pin 5 equal 1, okay. Now, if PA pin 5, 1, so they connect to U4 pin 5. Okay, U4 pin 5 equal 1. Okay,
Mm-hmm.
stop counting down.
Right.
Okay,
Okay.
that makes sense, right?
Mm-hmm.
Now, you go in here. When they go 15, okay, they count up 0, 1, 2, okay, and when they get this one, and they get a 1 again here, okay,
Where's that at, Mr. Pham? Do that again. I didn't see that.
okay, at this point here,
Oh, okay.
okay, so when they go to 15, okay, and you get a 1 here, 1 here,
Right.
so now you get the clock again, so they will be toggle, okay,
Mm-hmm.
toggle, so that's why U4 pin 5 go 1, and they start countdown, okay, so let's see, 0, they count down, they start go to 15, and then go to 14, and go to 13 again. That I have everything for count up or count down. For technician or engineering, when you're looking into the timing of every IC, you're able to recognize how they function. Okay? So, only thing I can say, when you count that the load, if they fail, then you can see output 1 or 2 or 3 or 4, which one will be fail. Then you go back into here. 18 fail, you go look into pin 2. If pin 2 correct, what can you do?
If pin 2 is correct,
But 18 is not.
right, okay. So that means the problem's inside the chip. You check, make sure 1 is grounded.
Perfect. Okay. So if the 1 is grounded,
And maybe we replace the chip.
not yet.
Not yet. Okay,
You
1
can
is
do. You can remove the wire from
okay.
pin 18.
Oh, I see. Okay. And then you check
18.
pin 18 with the wire removed.
Right. If they correct, that means the wire going wrong. You get that?
If okay, you remove the wire, you check pin directly on pin 18, and then you get the right information. So something's wrong with the wire or something you saying?
If you get correct at 18, that's the wire going wrong.
For give an example of the wire going wrong.
Right. Or the control box get a problem.
Oh, okay.
Either one. That is how troubleshooting.
Hey, Mr. Pham, so like on any of these outputs, like PCs, if you check pin 2468 and all of those are good, and one either whether it's Y1, Y2, Y3, or Y4, one of those are bad, by pulling the wire and checking directly on the pin, you're getting the what's coming from the A1, A2, A3, or A4, correct?
Right.
And then once you determine that, then you're saying it's got to be the wire or the control box.
Yeah, that is the way troubleshooting going from out back to in.
Mhm.
Or someone going from in back to out. When you wrong in 18, they check pin number 9. You find number 9.
Wait a
It's
minute, where you at? Number 9 on U5?
right,
That goes to 15 on U4.
right. To check you find number 9. If they correct, then you go to 15.
Right,
Okay?
correct.
Then you go to pin number 3
Hmm.
and make sure 11 must be low.
Correct.
Okay? And you keep going up to 18. That is going from input to output.
Right.
Or you go from out to in. Okay? However, for mine, I go in the middle. That means when they fail, I take QA pin 3. Okay?
Okay.
If they're correct, I go forward. I go this way.
You go to U3 pin 2.
Yeah, go this way.
Right. Yeah, yeah, you go to the right. I see what you're
If
saying.
they're wrong, I go this way.
You go to the left. Yeah.
Okay?
Yeah, that
That's
makes
it.
sense. That makes
Same,
sense.
same way. But this one will be take less time, less of time. The thing is you in the middle.
Hmm.
Either go to the right or go to the left. Okay? So
Hmm.
when you're doing your left, you're talking about that 191.
Right.
You got a problem with what?
Well, I get the reading. I get the wrong reading at port C, but
No, what that?
um, I don't have it hooked up right now. But uh, when I initially did it, it it ran and then it stopped. So this was the other day when Mr. Ty was in there, and he says I need to check my wires for ground.
No, not supposed to be.
I know, but he it might be intermittent. That's what I'm saying.
The thing is they not pay much attention in the program. The thing is now, Mr. Tai, he gets something else to do. So he's so busy.
No, no, I agree with you.
However, that's why if I retire, I will become another instructor. I tell him the dean, instead we get instructor, better get a technician assistant. Just go ahead and take care of the lab for the class. I need the people working with them. Like either in lab one, same thing. I don't want any instructor sit down. They have to go with the people to see how they do it. If the people not understand, that's why they quit.
Hey, Mr. Pham, though, but regarding my problem, um, is it's possible that like maybe my U5 pin 1 or my U4.
I don't know. Only thing is we have to see what the test they failed.
Okay.
Then I can tell you what to do.
Yeah. But I'm gonna check. I'll check it again, and then I'll let you know what happened on Monday.
Yeah. That normally I will be in the class on Monday, Tuesday.
Right.
Okay. And also in Tech One, I will be forced them to be in the lecture on Monday in the class.
Hey, let me ask you this then. What happens, or what do you think happens? I mean, I'm not an exact answer. What do you think happens? Like it's counting 1, 2, 3, 4, 5. Then it get to 6 and it fail.
Okay. So that can make sure 11 must not have to be 1. Okay.
Right, right, right. Load got to be 1.
They must be. Then you can they count to what number?
It counted up to 5 and it failed on
Okay,
6.
fail. So that's why you can take the output here. When you get a neck, they have to be number 6. Then you can check right here.
All right.
Make sure you get number 6. Okay?
Yeah, I get what you're saying now. I'm just bringing that up as an example so I'll know how to attack the problem. But yeah, I'm use the meter and then check it again. I don't have it in front of me right now, but when I get a chance, I'll check it again.
Okay? So
Yeah.
we'll see you guys on Monday.
Okay. Hey, Mr. Pham, thanks a lot. I got personal training today because there's only me, you, and one other person.
That's why.
Yeah.
Now, that's what I'm telling you. This time I change the way teaching.
Yeah.
I guarantee the student, when they looking the timing, they recognize everything.
They got to remember that you do Zoom on Friday now.
No, not Friday.
This is Friday.
I'm working on that. Okay. Take 2 or take 1. From next week, they will be in the Zoom on Zoom 240.
Who's that? Tech 1 or Tech 2?
Take 1 first.
And Tech, and okay, is Tech 2 going to be on Zoom in Friday next week?
No.
Where's Tech
The
2
thing
going?
is, I don't want the Zoom only you and another student. No. I don't want to waste the time.
Okay, so next Friday or next week, I don't know when, but
On Monday, let you know.
okay, on Monday. All right, you
The
let us
thing
know.
is, same thing happened for take 1. Yeah, yesterday. Just a 1, 2, 3 student. How come? So that's why I will be doing in room 240, and
Okay.
the lab must be closed
All
for
right.
4 to 5:30. No one in the lab for take 1.
Okay, well, let me ask you this question, Mr. Pham. On Monday, what time should we be there?
Now, normally I've been there from 3.
No. But you say you want us to.
Okay, normally your guy will be up there around any time. However, that for the take you to do the lab, so you can be going to the room.
Yeah, but what I'm
Hey,
asking you, Mr. Pham, what I'm asking you is, what time should Tech 2 be here on Monday?
let's see.
On Monday, what time should Tech 2 be here?
Okay, 4:30.
4:30. Okay, so on
4:30.
this coming Monday, Tech 2, 4:30.
Yeah. The thing
Okay.
is, take 1 will be 3:30.
Okay.
Okay.
So 3:30 to 4:30 you do Tech 1, and 4:30 to 5:30 you do Tech 2.
Supposed to be.
Okay. Well,
The thing,
anyway, any case, make a long story short, any case, Tech 2 come 4:30 on Monday.
yeah.
All right, that's what I want to know because I want to make sure I don't miss it.
The thing is, like take 1. If they not in the lecture room, I drop them off. Why waste the time? They cannot get out. If the website of the SDCCD problem with them, however, in the class, they must be in the lecture. As yet, no lecture, they not understand anything. How can they do? Keep doing. Okay?
All right.
Yeah. We'll see you.
Okay, Mr. Pham, have a good weekend.
You too.
Okay, bye-bye.
Bye-bye.